nanotechnology is small enough that it can pass through any barrier. And I think that's why we're seeing all the, excess mortality, increase in turbo cancers and diabetes, myocarditis, pericarditis, where the cell is only as healthy as its environment. And if you have positive nanocharged cells that are going to attract to the cell membrane, disturb the functionality of that, or provide an environment that's not conducive for a normal functioning cell, and that's going to alter, in other words, or cause the cell to adapt to this technology that had been introduced over several decades through various transfectors, such as chemtrails, such as air, water, food, pharmaceuticals, nutraceuticals. And what makes your invention so significant is the fact that there was nanotechnology that we were able to see using scanning transmission electron microscopy, using dispersive energy spectroscopy, using compound microscopes, doing identification of, to be able to see this both in the vial, that contained this liquid that looked clear, but you can't see nanotechnology. It's too small. Looking at this technology, you first have to understand what normal blood looks like. It's round and symmetrical, even in color, even in shape. When this technology was introduced into a vaccination program, things changed. And with the nanotechnology and its ability to self-assemble, could create threads, could create ribbons, could create clusters. Here's an example of what I'm talking about. This is a cluster of graphene oxide, and look what it's doing to the blood. It's taking it from normal into pathological blood coagulation. But they react to electromagnetic fields. And we can see this cluster of graphene oxide, which is cytotoxic, genotoxic, and magnetotoxic. We can see the fibers coming off this cluster, and it becomes highly electrical. But it can organize itself into threads, which act as antenna. So this material can be a receiver, a transmitter. Looking under an electron microscope, you can actually see then the activation when cells lose their ability to repel themselves. They start clustering, and this clustering can form clots, and that's what this is. This is a microclot seen, using electron microscopy and seeing the proteins, the fiber monomers cross-link. And here again, these are damaged cells. The body needs to remove those, and it's activated by graphene oxide, which carries a positive charge, so it attracts to that cell. So it's very important to realize that when this happens, this can lead to some serious challenges. When cells start to alter, this is when they start giving birth. Another electron microscopy picture that has been colorized. They start giving birth to new forms. So germs are not necessarily from the air that we breathe. I mean, you can breathe in the artifacts that have gone airborne from other animal, plant, or human sources. This is biological transformation as cells literally change their functionality and start giving birth to these particular forms we call bacteria or yeast or even mold.